So far, we have created classes that describe objects in terms of their properties or variables. In addition to attaching variables to an object, we can also attach functions to that object as well. For example, let's go back to the student class that we constructed last time. So here's our student class, and just to review, this student class has a single function into it called the init function. This is called our constructor. And your constructor runs one time when the function, when the class is initially built and an instance is created. This init function is designed to accept three arguments. The first argument is always sent to the init function. That's the self argument, and that is a reference back to the object that's being created. And the last two are the optional arguments that we've set up here. In this case, first name and last name. And what this constructor does is it says, go to the object that's just being created, create a variable on that object called first name, and put into it whatever is being passed in as an argument for the first name. So when we go ahead and construct a new student, we're going to send in Jane Smith. Jane and Smith are the values that we're sending in. They're going to go into these last two variables right here because self is automatically set for us. And then it'll go ahead and place those into the correct instance variables. So the init function here is technically a function, but it only runs one time. It runs when the class is actually constructed the first time. But we can also add our own functions into a class as well, further coupling data and actions together within one of these little coordinated units. So let's go and make a new function here. Let's say not only do students store their first name and last name, students also have the ability to, I don't know, say hi. So let's go ahead and give all students the ability to say hi. So we're going to say def say hi. So we're going to make a function called say hi. We're defining that function inside of the class, meaning that this function will go along with the class itself. Now this say hi function, just like the init function, will automatically be passed a reference to the object that is calling the say hi function. So whenever you create a function inside of a class, the first argument will always be this thing called self. Then what we can do is let's have this object say hi. So we're going to print out hi there from self.firstname. Now watch what happens here. When I construct a new object for Jane Smith, we're going to call the constructor, and Jane and Smith are going to go into the first and last name fields. And then I can have that object call its say, that's going to be a say y, not sai, say hi function. Note I don't have to pass it any arguments because the self argument has been pre-populated. And then watch what happens. When I call the say hi function, it's going to say hi there from Jane. Well, what happened? Well, we asked the object to call its say hi function. It printed out the string hi there. That's great. And then it referenced back to itself whatever first name variable it's currently storing in its instance variable. In this case, it was set up through the constructor to store the string Jane. So it's going to print there, hi there from Jane. And you can have any number of functions that you want inside of a class, and you can call those functions using dot syntax in the same way that we can call a function on a string. For example, word is equal to Python, and we can say print out word.isAlpha. IsAlpha is a function attached to the word object. Well, say hi is a function attached to the student object. We're essentially creating our own organizational structures, and we can use dot syntax to access what we want. So let's go ahead and make this a little more complicated. Let's say that in addition to a student holding their first name and last name, a student holds on to all of the grades that they've earned in a class. Now, a student might have multiple grades, so let's go ahead and set up their grades as a list. So when a student is constructed, not only do they hold on to their first and last name, but let's go ahead and make an empty list to hold all of our grades. So self.grades is equal to an empty list. Now, let's make a new function down here, and we're going to say let students print out their grades. Def print grades, self. And we can just print out self.grades here. So whenever we call the print grades function, the object references back to itself and prints out the grades list. Now I can say a.printgrades. And A will now go ahead and print out grades, and it should print out an empty list because there are no grades in that list. Now let's go ahead and make a new function to add some grades. So def add grades. The first argument is always self, and then the second argument is going to be the value. And then we're going to say self.grades.append value. So essentially what we're going to do here is we're going to say go to our grades list and add to it whatever value we want to add. So watch what we can do now. We can say a.addGrade. What do I want to add? I want to add 100. a.addGrade 90. a.addGrade 80. And then I can a.printGrades. I can ask the object to add in 3 grades and then print out the grades when they're finished. Now watch what happens. The first time we run it, we print out the grades, there's nothing in there. Then we called the addGrade function 3 times to add in new grades, and then we printed out the grades again, and look, the object kept track of all of those grades for us. It essentially allowed me to print out all those values. Now it's trivial at this point if we want to add in more functions. We can add in another function here called def, get average. Get average is going to, return the sum of our grades divided by the len of our grades. Now we can go down here and we can say average is equal to a.getAverage. This is going to go to the A object and say, hey, get your average. No problem. I'll go ahead and reference myself and sum up all of my grades, divide them by however many we have, and that should return to me the average grade. And then when I'm completely finished, I can go ahead and print out average here, and we should be able to see the average score come out there, which is a 90.0. So any class can have any number of defined functions inside of it. All of those defined functions are defined just like regular global functions that you would create in your regular program. The only difference is each of these functions is always automatically passed a reference to the object that is calling this function. We always refer to that as self. The function then invokes and has access to the object that called it and can reference any of the instance variables that went along with that object. In this case, our print grades, add grade, and get average functions all are able to reference the instance variables that were set up in the constructor up here. So this makes it an incredibly powerful tool for creating complicated, reusable patterns of information. This student class now not only has the ability to hold a first and a last name, it also has the ability to hold a list of grades. It can say hi, it can print out its current grades, add new grades, get its average. We can incorporate additional pieces of functionality in here, and the main programmer down here simply needs to know the names of the functions that it needs to call, and these objects will call their own functions, keep track of their own variables, and essentially keep track of their entire state throughout the entire execution of your program, cutting down on you having to incorporate an organizational structure to keep all of the information loosely bound together. This tightly binds and encapsulates the information, so it's very, very easy for you to keep track of what's going on and essentially makes it much easier to solve much larger, more complicated problems using Python.